seems a little bit more complicated than before. And so what's your hunch? What are we gonna do? Should we do a log diff here, or should we do a quotient rule here? Let's see. Since this is a complicated product and quotient of functions, let's apply logarithmic differentiation. And by doing so, take the absolute value on both sides. Since not every factor in this example is positive, we can proceed with taking the ln on both sides right away. So we have ln of the absolute value of y is equal to the ln of this thing. So we have, upon using the laws of logarithm, we have ln of the absolute value of 2x squared plus ln of cotangent 4x, the absolute value of that, plus, for the denominator we have subtraction minus ln of the cube root of 5x minus 2, then minus ln of logarithm of x squared plus 2 base 4, raised to x minus x squared. Okay. Then we have here 2 ln absolute value of 2x, right, plus ln cotangent of 4x minus 1/3 ln of 5x minus 2 for this one. And lastly, we have quantity x minus x squared ln of logarithm of x squared plus 2 base 4. Okay? Plus 2. Then we can implement implicit differentiation on both sides, right? So the derivative looks like, of the left side is 1 over y times y prime equals 2 times the derivative of ln of absolute value of 2x is 1 over 2x multiplied 2, the derivative of 2x is 2, plus the derivative of this one is 1 over cotangent 4x multiplied to the derivative of cotangent 4x, which is negative cosecant squared 4x times chain rule, the derivative of 4x is 4. Okay, minus, let's put it here, minus the derivative of the third term is 1/3 times 1 over 5x minus 2 multiplied to the derivative of 5x minus 2 is 5, minus, what's the derivative of this thing? This makes use of a long product rule. So let's try it. This thing has a derivative of left to right plus right to left. Okay, copy the left, x minus x squared, then multiply it to the derivative of the right side. We have derivative of ln is 1 over what's inside, logarithm of x squared plus 2 base 4, right? Then we need to multiply it with the derivative of the next inner function, and the next inner function is the logarithm of x squared plus 2 base 4. So recall, the derivative of logarithm of x base, say b, is equal to 1 over what's inside ln of b. Let's try it. So what's the logarithm of this thing? That's 1 over x squared plus 2 ln of 4. Are we done? Of course not, because there's still an inner function in here. So it's the derivative of x squared plus 2. That would be 2x, right? So that's only the first part, the first term of our product rule. Left the right. We need to add right the left. So right the left is just ln, copy the right side, logarithm of x squared plus 2 base 4, left the right times derivative, right the left, derivative of left is the derivative of this polynomial, 1 minus 2x. So that's it. That's quite long, right? But we need to bear with it. Now let's simplify the right hand side. Also, can I isolate y prime na? Lipat ka na yung y sa kabila by multiplying y on both sides. Okay? So we get y prime or dy dx to be, let's pre-multiply y on both sides. So we'll have y times this entire thing. But this entire thing looks like, okay, let's do this. So we cancel out. Have a 2 over x for the first term. Plus, sorry, that's not a plus, since we have a negative here. So minus 4 times cosecant squared over cotangent 4x. Actually, okay na yun, pero if you're so OC about simplifying everything, cosecant squared 4x over over cotangent 4x is equal to, by basic identities, fundamental identities in trigo, by reciprocal identities, cosecant squared is 1 over sine squared 4x. All over cotangent 4x is cosine 4x over sine 4x. This complex fraction becomes 1 over sine squared 4x multiplied to the reciprocal of the main denominator, which is sine 4x all over cosine 4x. This will cancel out, so we'll have a 1 over sine 4x times cosine 4x remaining, or by reciprocal identities again, this will become cosecant 4x secant 4x. This means that this next term is negative 4 cosecant 4x secant 4x, since this thing here looks like this. Okay? Minus, the third term is 5 over 3 times 5x minus 2. Okay tayo doon? Then, for the last two terms, can I distribute this negative sign on both terms na? So I can have minus, the numerator is just 2x times x minus x squared all over, the denominator is this whole thing, ln of 4 times x squared plus 2 times the logarithm of x squared plus 2 base 4. Okay, minus this thing, 1 minus 2x multiplied to the ln of logarithm of x squared plus 2 base 4. Then lastly, transforming y to its original form gives us this derivative. Okay? It's quite long, sorry. Okay, let's go to the next one. We are to differentiate this function y equals the cube of hyperbolic secant e raised to 2x multiplied to the inverse sine of 2x. What can you notice here is that there is no function involved wherein it is of the form f of x raised to g of x, tama? Well, you can use log diff dito, but it's not too complicated naman to use power product rule instead. So in here, probably we can get away with log diff, but to use product rule right away. So we just need to remember what's the derivative of the functions involved. So we know that dy dx is left the right plus right the left kapag meron kang involved na product. So we copy the left. Tama. Then multiply it by the derivative of arcsine. So in this side lang, recall, the derivative of arcsine with respect to x is 1 over square root of 1 minus what's inside squared. Yun lang naman, no? So left to right is just left times the derivative of arcsine is 1 over square root of 1 minus what's inside quantity squared. Do you follow? But what's inside arcsine is still a function of x. Hence, we need to multiply it by the derivative of 2x, which is 2. Tama? So that's left the right. Next is plus right the left. The function at the right is the inverse sine of 2x. And the function at the left is the cube of hyperbolic secant of e raised to 2x. So this is a composition of functions. Pero yung outermost function ay naka-cube si hyperbolic secant. So we need to differentiate first that outermost function. So we are to get 3 times the hyperbolic secant raised to 3 minus 1 by power rule. E raised to 2x, tama? After which, we need to multiply this by the derivative of the next function going inside, which is hyperbolic secant. Or recall lang, what's the derivative of hyperbolic secant? The derivative is the same as the usual secant, but it's just negative. So the derivative of hyperbolic secant is negative hyperbolic secant hyperbolic tangent of what's inside, of course. No? So the derivative of hyperbolic secant e raised to 2x is negative hyperbolic secant of e raised to 2x hyperbolic tangent of e raised to 2x. Do you follow? Then, since what's inside hyperbolic secant is still a function of x, and that's e raised to 2x, just need to multiply this by the derivative of e raised to 2x, which is e raised to 2x times 2. Tama? If in this course, hindi na kailangan i-simplify, this is already acceptable. Okay tayo doon? See to item E. In here, you have hyperbolic cotangent y equals ln 2x minus 3y plus cosine 3 raised to x. So do we need to use logarithmic differentiation here? Well, we do not have a complicated function though. I mean, we do not have a combination of quotient, products, and powers on any sides. The alternative solution is probably we can use exponentiation. We can transform any f of x raised to g of x into an e raised to g of x ln of f of x. We don't have any of that form. We don't have f of x raised to g of x here. Differentiating both sides, we'll have what's the derivative of hyperbolic cotangent. So what's the derivative of the hyperbolic cotangent? That is negative hyperbolic cosecant squared y. But since y is a function of x, we need to use chain rule. The derivative of y is y prime or dy dx. Okay, then for the other side, what's the derivative of ln? That is 1 over what's inside, right, multiplied to the derivative of what is inside. What's the derivative of 2x minus 3y? That is 2 minus 3y prime. Okay, plus lastly, what's the derivative of cosine 3x? It is cosine 3 raised to x. It is negative sine 3 raised to x multiplied with the derivative of what's inside. What's the derivative of 3 to the x? You know that is 3 to the x ln of 3. Then combine all the y primes. So probably we need to distribute these this term first to those. What's inside? We have negative y prime cosecant squared, hyperbolic cosecant squared y equals 2 over 2x minus 3y minus 3 over 2x minus 3y y prime minus 3 to the x ln 3 sine 3 to the x. Transposing this term to the other side, we'll have negative y prime hyperbolic cosecant squared y plus 3 over 2x minus 3y y prime equals 2 over 2x minus 3y minus 3 to the x ln 3 sine 3 to the x. Factoring out y prime will have y prime times negative hyperbolic cosecant squared y plus 3 over 2x minus 3y equals 2 over 2x minus 3y minus 3 to the x ln 3 sine 3 to the x. They follow. Then last thing we need to do is we need to divide both sides by this entire factor. Dividing both sides by negative hyperbolic cosecant squared y plus 3 over 2x minus 3y negative hyperbolic cosecant squared y plus 3 over 2x minus 3y. This will cancel out. We'll get y prime to be this thing. So let's just simplify this complex fraction. For the numerator, we'll have an LCD of 2x minus 3y, and we have 2 minus 2 minus, let's combine this, 2 minus 3 to the x times 2x minus 3y, right? ln 3 sine 3 to the x. Am I correct? All over, let's combine. We'll have again an LCD of 2x minus 3y. Then the numerator is negative quantity 2x minus 3y, or 3y minus 2x hyperbolic cosecant squared y plus 3. Then this complex fraction will be reduced to, so how did that happen? Reciprocate this, turn this fraction into product. So you know how to simplify a over b over c over d. That's just a over b times d over c. Apparently, these two are the same, so it canceled out. Okay? So please verify that. This is dy dx. Can you simplify this further? I guess we're okay with this.